Hi, folks. My name is Jibo, Sanyal, and so thank you very much for that generous introduction. I'm a team lead at Oak Ridge National Lab. I work in the area of geocomputing. So first question often is, what is geocomputing? I would describe it as using computers to solve problems that are related to anything geo, anything that has an aspect of space and time as it relates to the Earth. So this could be urban environments, this could be long-term weather, this could be mining, looking at coal, looking at resources, looking at how our energy sector is and how resilient it is, aspects of situational awareness, and computing, and how to solve these problems that we face using computing. That's what I do. I figured it would be interesting to put a picture of the world and talk a little bit about how I came here. So when I was invited to this talk, I began to wonder, where do I start? And I put myself in your shoes and figured, let me start all the way from when I was tiny. So I grew up in a place named Shillong in India. And it's roughly there. It's not, these are the Himalayas. It's not in the Himalayas. It's not in the foothills either. But it's still 5,500 feet above sea level. And so, gorgeous. And eerily similar to the Smokies and this area. So I feel very much at home. Waterfalls, rolling hills, mountains, and a city tucked away at about 5,500 feet. We never had summers, which might be a little bit surprising when you hear India. You think hot, right? If we had a 78 or 80-degree day, that would be the hottest in like 5 years. So yeah, I mean, I grew up there, went to school there, and one of the things that I was very interested in as I was growing up was geography. It just fascinated me when I would read about how glaciers, melt and turn into streams, and eventually, when it rains a lot, they flood, and then humans are displaced. It affects us all. Processes of how we have rain, condensation, different kinds of clouds. It just fascinated me. At the time when I was growing up, this was late 80s, early 90s, the economy of the country was beginning to grow in a fairly significant way. But still, the opportunities of pursuing disciplines that were related to, say, psychology — my wife's a psychologist — or for that matter, history or the performing arts, they weren't very popular because engineering was safe, medical was safe. And so as much as I wanted to pursue something in geography, the education structure, the system of the education there didn't quite facilitate it. Meaning, as you would go from your 10th to higher degrees, you would have to choose between one of three: the sciences, anything related to commerce, as in economics or any such combinations of subjects, or you would pick something from the humanities. And somehow, I don't know why, geography would always be clubbed with the humanities. And so after a lot of deliberation, I figured, I enjoy computers almost as much as geography. It's safer, so it would probably assure me a decent job eventually. I went with computing, and of course thoroughly enjoyed it because I loved computing too. Now it has changed a lot. I see my cousins and their kids, they're picking up things like journalism because the economy has come along that much, and that's pretty amazing. So you might be wondering, how did I come back to geography? I'll come to it. So after I finished up part of my education in Shillong, I went to finish a part of my studies in Calcutta. It's now called Kolkata. Have you guys heard of this place? It's a pretty well-known place, pretty big place. It's massive. 18 million people maybe, 15 million people maybe, I don't know. About 5 to 6 million people go in and out of the city every day. That's like the population of Atlanta. They come in, in buses, trains. It's a massive network of, sorry?
Planes.
Yeah, planes. It's a massive infrastructural network, and they do their job, work in the downtown, go back. It's also very famous for Mother Teresa. She's now a saint, but people just refer to her as the mother. She's very respected there. I'm 2 degrees from the mother. I know someone who has met her. And just to see the kind of work she has done there is pretty amazing. So I went to the University of Calcutta there. I spent a few years studying there. And that's where I met my then girlfriend, now wife. She was in psychology. I was in computing. We got along. After that, at that time I was doing computing. I got a job in a fairly nice, it's a fairly good company. Just like here, over there too, you have different companies that list which are the best places to work for. So I worked for a company named Saskin. And interesting company because you wouldn't hear of them. But what they would produce were everything that goes inside a mobile phone. And so they were a B2B company, as in a business to business, not a business to consumer. Like if you go buy stuff from Walmart, that's a business that sells to a consumer. A B2B is a business to business, so they sell to another business. So Saskin produces, or at that time, I don't know what they do now, at that time produced all the software that would go into Motorola cell phones and Nokia cell phones. And so they would buy it from them. And they would add stuff to it and brand it and then sell it. So I worked in what was then 3G, which was latest and greatest. It was coming. It was still not there. And I worked in the product integration team, where what we would do is we had a bunch of offices. We had 2 in Bangalore, 1 in Pune, which is another city in India. Actually, I should forward that. So there's Bangalore, and Bangalore is again a boom town. It used to be a retirement paradise, and just like a pillow that goes poof, in about 15 years or so, it became a major, massive city. About 12, 14 million people maybe, I don't know. But anyway, working on mobile products was awesome because I was working with teams that, we had one team in Kiev, one was in Mexico, Guadalajara, and then we had another group that was working out of Silicon Valley. So it was interesting because during the day we would work there, people would work in another time zone, and then we would integrate. It was pretty interesting. I learned a lot. So how did I end up in the US? I think the credit goes to my wife. She always wanted to pursue a higher degree. She wanted to get a PhD. Her dad was a professor. My dad was an engineer. So I had an engineering mindset. She was more academic, and she always wanted to do more with her life. And the truth is, one fine morning I woke up, in Bangalore. I was in the 4th or 5th floor apartment I had, and I looked out of the window and I saw this vastness of the city, and over 50% of the city is actually writing some kind of computer code. And I wanted my computer code to have more meaning. I wanted it to do more stuff than just the next cell phone. I mean, sure, a cell phone is pretty awesome and cool and all the technology that goes into it. But I wanted it to do more. And so that's when application to grad school started. And I think that's where the United States shines. The quality of educational institutions, the A-tier institutions, the B-tier institutions, even the C+ tier institutions, they are just fabulous. And so both of us started the process of trying to find a good school to get a degree in. She had a bunch of schools that she got into, and then I got into a few schools, and they didn't quite exactly overlap. I had an admit from University of Chicago, one from Syracuse University, and then a couple of others, I think. I had one from University of Utah, maybe. Can't remember, it's so long ago. I ended up in Mississippi State because of which project I was going to work on. So as you go into grad school, a lot of these professors are looking for students whom they fund to actually attend school, so you get paid actually to attend and get your PhD degree, master's, PhD sometimes. And through you, they get their research done, but you get paid for it. You have to work a little harder, but it's so rewarding. And so the project that my advisor and my mentor there had was a project that was from NASA. And this was about how can we take all this humongous amount of data that's coming down from all these Earth observing satellites. How do we take this data and begin to create a system that helps scientists formulate questions? Like, I want to study this, but usually 70% of the time they're wrangling with the data. So can we build a rapid prototyping tool for them where they can pull the data they need and be able to answer some of their questions? Phenomenally interesting work. Then I started working on actually, I skipped a few slides. This. So what you're seeing here is a hurricane model output. This was part of a NOAA project that we worked on, which was about how can we produce more value for scientists so that they can actually have better insight into their data. So what we did is we were working with a few meteorologists. We took output from what was Hurricane Lily. This was a unique hurricane in the year 2003. What really happened was it went from a category almost 4, it was like the high end 3, to barely a category 1 in a span of about 13 hours. And this happened over the sea before it made landfall. That never happens. When it's over the sea, it's getting all the moisture from the ocean surface, and it's only intensifying. The sea surface temperature, which there's certain conditions for it to happen, like the sea surface temperature has to be above 82 degrees. All those conditions were perfect, like the perfect storm. But it just fizzled out. So they wanted to understand what really happened, because that doesn't happen. So we were working with Pat Fitzpatrick, who is a professor at Mississippi State, but also he works at the Stennis Space Center, NASA's Stennis Space Center in Mississippi. We had a few other people, Robert Moorhead and a few other people who were working on this. So what he did is he ran some simulations, so some computer simulations to see what was going on. He had set up these 2 experiments. One was just run the model as is and see what happens. And another, introduce satellite observed data into it to help with the initial conditions and see what happens, compare between them. So what I did was I took these 2 outputs, and they were all on a 3D grid, you can imagine. So it's the 3D volume of the Earth, right? And so you have latitude, longitude, and elevation. So it's essentially layers of simulation output, and over time, as in how it evolves. So what I did was basically took the output that did not have any satellite data and basically just subtracted it, each grid point with the other. And so now I had a volume that was a difference volume. Wherever they agreed, it would null out to become 0, right? Wherever they did not agree, one would be far on the negative side while the other would be far on the positive side. So I would essentially have difference values. So I took that and I plotted it on a green to a transparent to a red color scale. So when you look at it in 3D space, everywhere where it's 0, you see through because it's transparent. But wherever it's red, it's leaning more on one side for essentially one model. And wherever it's green, it's leaning towards the other. And so I didn't find it, but I just illustrated it, was this patch of red here. And this was done in a 3D environment, so wear those 3D glasses and you're able to sit in there and data is all around you. You can turn things around, look at interesting structures. And what we found was there's this patch of dry air over the mountains off of Mexico. It was very dry, so dry that it literally just chopped off the hurricane. That was a very interesting discovery. We got a bunch of really nice publications out of it, and actually got a Best Poster award also, and that felt awesome. It also helped me get jobs later on. Well, I want to take a step back and make a point here. So I went to Starkville, Mississippi State University, and I did things that I've never done in my life. Like, I was coming from cities like this to a really nice, serene place. So we had a garden. We went fishing. These are things I would have never done in my life had it been lived my life in Bangalore, And the people, and the food. 5 of the best years of my life, I gotta tell you. What did happen though, my wife ended up in Southern Illinois University for her PhD, and so I could tell you For 5 years, we did that. And then actually, when we got jobs, I ended up in Oak Ridge, and she ended up in DC. And this was in around the 2008, 2009, and economy was bad, and everybody said, you have jobs, take it. So for about 7 years, we ended up in 2 different places. Wasn't easy, especially when you're coming from another country. There's just a bunch of legal stuff that gets in the way from just staying in one place. So for about 5 years, I could tell you every pothole on I-55 going north. And for the remaining 2 years, I could tell you every pothole on 81 going to DC. But again, unlike a lot of people who come in from various countries, a lot of the people go into reasonably big cities. We were lucky in the sense that we could experience, we knew what a big city was. They're all the same. Calcutta is the same as New York. Nobody has time for anybody. But I shouldn't say that. They're very nice people also. Some of the best people I've met are in both those cities. But what I'm trying to say is that we experienced the country and the people and the culture in a way a lot of people do not. And we're very appreciative of that. Very generous people. So moving on. About the time when I was looking for a job, well, you apply to a bunch of places. So I had a few job offers. I had one from Oak Ridge, and that happened through a person who I eventually worked with. We were at a conference, and we were co-chairs, and we've known each other for a while, Joshua. I also had an offer from the Scientific Computing Institute, which is in Utah, and then one from Lawrence Livermore National Lab. And they're all very fabulous places to work. What happens is, in the pipeline of when you get a job offer, they don't all come together, and you just don't get to choose from, okay, I've got 5 picks, which one do I take? That usually doesn't happen. You have like a week or 2 to decide at most. And so Oak Ridge happened before the others, and never regretted it. It's been awesome. I started with running simulations on buildings and energy modeling for buildings, how it impacts us. We all have building energy codes, right? Buildings are built to code, but then the codes are from 30 years back. They use the last 30 years data, 20 years data in some cases, and have codes. But essentially, when you have a new house, it's built for the past, to paraphrase one of my colleagues. So we worked on understanding how these codes could actually be improved, what kind of techniques could help inform a better energy footprint, so that eventually, we can actually reduce our bills for sure, but overall impact of energy. Came to learn about things like at 5 o'clock to 6 o'clock in the evening, we have a peak demand. That's because everybody's either going back home or going out to eat, and energy demand just goes up. What that means is that we are trying to produce clean energy. We want to produce clean energy. It's not nice to burn stuff up. That's what we've been doing, right? Digging stuff up and burning them into the air. So things like using nuclear energy, using renewable sources of energy helps mitigate some of those. So what the power producing companies do is they try to only bring online their coal-fired generating plants whenever they cannot meet the demand. And that happens in the evening. So imagine when everybody has an electric vehicle, we come back from work and we plug it right in. That demand is only going to go up. And so there's a lot of research going on in Oak Ridge to try to understand how can we mitigate some of these energy challenges that are imminent. It's coming. So I worked on some of those. And then eventually an opportunity opened up where I applied and ended up getting a team lead role. And this is where it's been going back to some of the things that I cared about a lot, which is the geographic information sciences, about the sciences, how it affects us, how it affects the planet, and so forth. During my PhD, sure, I worked on things that were very related to geospatial, but now more so in a careeristic sense, I'm in that space back again. We work now on various kinds of things. We use Titan, which is a massive, massive computer in our backyard. It was the world's most powerful supercomputer for a while, and now we are building another one that's about 10 times bigger. You might ask, why do we need such a big computer? I often get asked that question. Some people ask me, can you play computer games on those? Like, Sure, you can, but is that what you want to do with such a big computer? You get by with your Game Boy. So why do we need such a big machine? It's because some of the problems and the answers to them, a big machine such as this gives us that amount of computational power that allows us to get to some of those answers in a reasonable amount of time. Like, for example, the weather research and forecasting model, which I've used quite a bit, is used to predict weather, like from the weather.com or National Weather Service that we get. It uses WRF and a few other models. To get it to run, say, for a longer period of time at a very high resolution, which is, say, at a resolution of half a mile. So you have a dot that says this is the temperature every half a mile, and you have a large grid that is large enough that you can have a very high resolution simulation. It becomes exponentially expensive to run those simulations as the size increases. And you want to do it because if you're just simulating for a little square, there's a lot of things going on the sides, right? It influences it. These are called boundary conditions. And then even within those grid cells, you're approximating. And so the finer it is, the better it is, assuming we have the physics figured out that it can actually do justice to that resolution. Because what happens is, the finer the spatial resolution, aspect of time comes in. I'll give you an example. Population of the state. Population of the country, we do a census every decade, right? Yeah. But when we look at a state, we want to find out what's happening every year. When we look at a country or a city, we want to find out what's happening at an even finer resolution. When we look at transportation planning, we look at how many people are going in and out every day. Or in other words, the smaller the space, the more the flux of things. So you want to compute it. So there's this relationship between space and time that simulation models have to account for as they run. And that's why big machine helps a lot. I think this was my last slide. But yeah, I'm working on some other very interesting projects too. I mentioned situational awareness earlier. And we now run a project for the Department of Energy, which is the official channel for situational awareness in the energy sector. Or in other words, what's happening in the energy sector right now? Where are we seeing outages? Where do we see pipeline issues? What does the flow of energy look like for the nation? The next step after situational awareness is, well, once you're situationally aware, the next thing is you want to be able to anticipate what's coming. So that's where the power of data and analytics can help you understand what might be coming. So yeah, that's what I do. Like my previous speaker, I also have a shout out to the girls. I want to say that where I grew up in India, every year, and you can look it up, every year, for the national level examinations, they have so there's the school boards, some are at the national level. They publish the statistics of how well the two genders are doing. Girls always beat the boys, by at least 2 percentage points. Look it up. That's all.